So in this part, now you're going to see how I'm going to identify the asymptote, the intercepts, the transformation, and the domain range when given a function or an equation. So just be mindful that with a reciprocal function, typically you just have a number in the numerator, meaning a number with no variable at the top. And in addition, the process that I'm going to show you here is going to be similar to 8.4, but just keep in mind that the process that I'm showing here will mainly pertain to the reciprocal function. So let's take a look at our first example. F of x equals 3 over x plus 1 minus 2. Now, according to the previous section, the previous video, I mentioned that this number is going to be related to the horizontal asymptote. So, since it's minus 2 after the fraction, then my horizontal asymptote will be y equal to negative 2. Now for vertical asymptote, it's going to pertain to the number with the x in the denominator, so I'm going to set the denominator x plus 1 equal to 0. Now the reason I can start that right away is because in the fraction it's already factored in simplest form. So I'm just going to take the denominator, x plus 1 equal to 0, subtract 1 on both sides. So my vertical asymptote is x equals negative 1. Next, we're going to focus on finding the X-Intercept and the Y-Intercept. So let me do the Y-Intercept first because it's a bit easier. So for Y-Intercept, you're just basically going to plug in 0 for all the x. So let me label Y-Intercept. So it's going to be 3 over, instead of x plus 1, it's going to be 0 plus 1 and then minus 2. And then what I'm going to do is simplify the denominator. So your fraction is going to be 3 over 1, because 0 plus 1 is just 1, and then minus 2. So I'm going to simplify 3 over 1, which is just 3, and then minus 2, so it's going to be 1. Therefore, my corner point is 0, comma 1. That's going to be my y-intercept. What I'm going to do is going to write the y-intercept over here so that I can have more space. So y-intercept 0, comma 1. Now for the x-intercept, it's going to be a bit different compared to what we did in 8.4. So for x-intercept, excuse me, where it says f of x, that's where I'm going to put 0. So the whole equation, 3 over x plus 1 minus 2 will equal to 0. So in order to solve for x, especially when x is in the denominator, we're going to do this one step at a time. So what I'm going to do is I'm going to cancel out the minus 2 since it's not part of the fraction. So I'm going to add 2 to both sides. Add 2 on the right, add 2 on the left. So I'm going to have 2 equal 3 over x plus 1. So after that, once you see that it's a number equal to the fraction, in order to work with the denominator, I'm going to multiply both sides by the denominator. So I'm going to multiply the right side by x plus 1, and then multiply the left side by x plus 1, in parentheses. So what's going to happen on the left side is I'm going to distribute the 2 to the x and the plus 1. So we're going to have 2x plus 2 equal. Now over here, when we're multiplying the fraction by its denominator, these two will divide into 1, and I'm just left with the numerator, so it's going to be equal to 3. From there, when we're solving for x, what I'm going to do is I'm going to subtract 2 to both sides. So we're going to have 2x equal 3 minus 2 will be 1. So I'm going to write over here for more space. So 2x equal to 1. And then from there, I'm going to divide both sides by 2 so that I can solve for x. Divide by 2 on the left, divide by 2 on the right. So x equals 1 over 2. Then I'm going to write my X-Intercept as a corner point 1 over 2, comma 0. So this is the work when finding the X-Intercept. And I'm going to write the corner point of the X-Intercept over here. So 1/2, comma 0. Now you could also convert it into a decimal, which is basically 0.5, comma 0 for the X-Intercept. So I'm going to erase the work. Let's talk about transformation. So, as I mentioned in the previous video, any number that's behind the x is going to go left or right. So in this case, if it's x plus 1, it's going to shift or moves left 1 unit. Now the other part, if you have a number behind the fraction, like the -2, then it's going to go up or down. So for this example, since it's -2, it's going to move down 2 units. And that's the only transformation that we have in this example. Now let's talk about domain and range. So for domain, it ties into the number that's with the x. So I mentioned in the previous video where the domain, it goes forever towards the left, negative infinity, and forever towards the right, positive infinity. But the middle part where the vertical asymptote is located, the graph doesn't connect. So it's going to be all real numbers, or all reals, as I'm going to write here, all reals, except what my vertical asymptote, -1. Now for range, as shown in the previous video, you saw that the bottom part goes forever towards negative infinity and the top part goes forever towards positive infinity. But it doesn't connect where the horizontal asymptote is located. So in this case, our horizontal asymptote is -2. So for our range, I'm going to write all reals except -2. And that's all you have to write for domain and range. Now just to review, the horizontal asymptote y equals -2 is connected to the number that's behind the fraction. It also connected to my range where I stated all reals except for -2. And for transformation where we wrote moves down 2 unit. Now for the x plus 1, that's connected to the vertical asymptote. When we solve, we got x equals -1. It also connected with the domain, all reals except -1. So see the connection there. Also see the connection for x plus 1, we wrote moves left 1 unit. So here's the information for asymptotes, intercepts, domain and range, and transformation. But for the graphing part, we're going to use the asymptotes and the intercepts. So in this part, we're going to focus on the graphing, and we just mainly need to have horizontal, vertical asymptote, X-intercept, and Y-intercept. So let's plot our horizontal asymptote first. So y equals -2. So it's going to be below at -2. So here's -1, -2, my horizontal asymptote. Now for the vertical asymptote, x equals -1, that's going to be towards the left side. Here's -1, so let me graph the vertical asymptote. Now let's plot our x and y-intercept points. So for our x-intercept, it's going to be at 0.5, 0. So 0.5 is on the x-axis between 0 and 1. So 0.5 will be right here. So I'm trying to mark in the middle between 0 and 1. And then our y-intercept is going to be on the y-axis. So 0, 1. So x at 0 and then 1 right here. So what I'm going to do is I'm going to start graphing. Since we have our 2 points here, and I'm going to zoom in a bit. So what I'm going to do is I'm going to graph along the vertical asymptote and the horizontal asymptote while I'm going to go to these 2 points, the y-intercept and the x-intercept. So I'm going to start right here, going along the vertical asymptote. As I approach the y-intercept, I'm going to start curving, going to the y and then going to the x-intercept. Then I'm going to approach the horizontal asymptote, so I'm going to go along with it, but I'm not going to cross nor touch it. So there's my graph. Now, one great thing about the reciprocal function when it comes to graphing is that the other graph will be diagonally across. So since I graph at the top right, then the second graph will be at the bottom left. And you don't have to be accurate, just be precise. So I'm using the horizontal asymptote and the vertical asymptote as my guide, and that's my graph for this example for this reciprocal function.